So, I'm going to start with the review over 7.4 and 7.5. And what you will have to know is when it says to make a table of the joint relative frequencies, you just have to know how to find those. So remember, you take your value here, and you do have to find the total, or sometimes they give you the total in the problem. There are 25 total. So to get this 0.36, you just do 9 divided by 25. Okay, that's how you get these. Okay, this one is 8 divided by 25, and then the total is just adding them together. So this one for the no would be 3 out of 25. This one would be 5 divided by 25, and then you add for the total, and then you add the total in the columns as well. Do you guys have any questions about making the table? Making the tables good? Okay. All right, then for B, it says if you are given that a 17-year-old has a job, what's the probability that the 17-year-old also has a driver's license? Anytime they tell you that something is given, that goes in the denominator. So if you're given that they have a job, you're going to have to find the total that they have a job, which would be job, yes, 0.48. That goes in the denominator. On the top is going to be that they also have a driver's license. So job and driver's license. I put job in DL. So has a job, yes. Has a driver's license, yes. Would be the 0.36. And then it says to round to the nearest hundred, so that's what we're doing. Okay, 0.36 divided by 0.48. All right, and then for this one, it says if you were given that a 17-year-old has a driver's license, so the given is that they have the driver's license, okay, and that's going to be the yes in the column for the driver's license, which is 0.68. What's the probability that they also have a job? So the numerator here is the same as this one. They have to have a job and a driver's license, and then we divide to get 0.53. Okay, do you guys have follow-up questions for me on those two? Good? All right, how's the mutually exclusive stuff?
Good.
So what does mutually exclusive mean? Good. Okay, so you do have to know that. Can't happen at the same time. Okay, and then make sure that you identify like yes or no. So yes, mutually exclusive, your card can't be blue and red at the same time, or you can only draw one card and that has one color on it. Okay, and then for this one you can say no because there are 2 black cards that are also 10. It's the 10 of spades and the 10 of clubs. Okay, feeling good about those, mutually exclusive? Can't happen at the same time, okay, on one of your draws. All right, now for number 4. It says apples are in 1/4 of all the lunch bags that are distributed at the school picnic. Bananas are in 1/3. What's the probability of randomly choosing a lunch bag that contains either an apple or a banana? These are mutually exclusive in this case, so you don't have to subtract the overlap. So anytime you have the or, this is your equation. It's the probability of A plus the probability of B. So the probability of getting an apple plus the probability of getting a banana. Now, once you have these, the 1/4 and the 1/3, remember, you can't add unless you have a common denominator. So your common denominator here is 12. Okay, so multiply by 3/3, multiply this one by 4/4, 3 plus 4 is 7, and the denominator is going to be 12. All right, and then the next one, this is another or, and there is no overlap. Okay, they're not going to both Costa Rica and Bermuda. So the Costa Rica is 15% or 0.15, Bermuda is 25%, which is 0.25, which is 0.40. Because it doesn't say to write this as a decimal, we do have to write it as a fraction. But we know that any decimal or any percent just goes out of 100. So if you have 40%, we just write 40 out of 100 and then reduce. So first you can divide by 10 and then divide by 2 and then you should get 2/5. Okay? Alright, and then for these next ones you are going to get some overlap. I told you while we were doing this in our notes that if you're ever in doubt of whether you have to subtract the overlap, just always do it. Because if the probability of getting both is 0, it won't affect you at all. Okay? So 6, she rolls a 3 out of 6. There are 2 options out of the 6 sides, so that reduces to 1/3. And yes, you do have to have your reduced fraction. The even number, 2, 4, 6, is 3 out of 6, or 1/2. Pam rolls an odd or an even number. Well, that's the whole cube. That's 6 out of 6, which is 1. That's 100% certain that that's going to happen. Okay? And then Pam rolls an odd number or a 3. So you have to do the probability of it being odd plus the probability of it being a 3, and then subtract the overlap. So the probability of it being odd is 3 out of 6. There's only one side with a 3, and there's only one side that's both, an odd and a 3. Okay, so this would be 3 out of 6, which reduces to 1/2. Okay, for 10, she rolls an odd number or a number greater than 4. Notice that these are all or problems there. Okay, so it's the probability of it being odd, 3 out of 6. The probability of it being greater than 4. What are our only 2 options that it's greater than 4?
5, 6.
Yes. Okay, so I know it was small, but I did squeeze it in there. Okay, so 5 or 6. That is 2 out of the 6 sides that are possible. And then the probability of it being both. The only odd number greater than 4 is 5. So there's only 1 out of the 6 sides that could give you that. So then we're just going to add the fractions. Okay, so you should get 2/3 when you reduce. Okay, so 4 out of 6, which reduces to 2/3. Any questions for me on that set? All right, now for this one, the Venn diagram, it says of the 65 students going on the soccer trip, 43 are players, 12 are left-handed. Okay, so 43 players, that is the total number of players. Okay, and then 12 is the total number of lefties. That includes people who are both. It says only 5 of the left-handed students are soccer players. So when you are setting up your Venn diagram, the first thing I would do is put the 5 in the middle. Okay, and then you guys can see I put my work above. So if there are 5 that are both, you just take the total and minus the both to get how many are only soccer players. So if 43 are soccer players, okay, 5 are both, 43 minus 5 is how you get the 38. Okay, and then this one, the left-handed, if there are 12 total, minus the ones that are both, that's your only lefties. Okay, so is that good now? Alex, is this one good?
Yeah. I did it right. I just didn't do the Venn diagram right.
Oh, okay, yeah, so did this make sense? Like you do this part first and then you do the subtraction?
Yeah.
Okay. Yeah, great.
So, the total number of players, 43. Wouldn't you
Soccer
subtract
players.
what?
Yeah, the 43 are the soccer players.
Yeah.
Mm-hmm.
Wouldn't you subtract 7 from it? Because then that would get rid of the 7 left-handed.
No, so you want this whole oval to add up to 43. So if you know that 5 are both, the ones that are only the soccer players, you do 43 minus 5.
Oh.
And it's the same thing here. So you want this whole thing to add up to 12. Once you know that 5 are in the middle, you can just subtract it to get the left-handed. Now, it asks you to find the probability that one of the students is a soccer player or is left-handed. So you have to do the probability of all the soccer players, so 43 out of 65, plus all the lefties, so 12 out of 65, minus the ones that are both, and that's 5 out of 65. So 50 over 65 reduces to 10 out of 13. Okay, and then 12 and 13, both of these have overlap as well. So drawing an odd number or a multiple of 7. So if you have the cards numbered 1 through 25, you need to write out all the odd numbers. Okay, 1, 3, 5, all the way up to 25. Okay, so there are 13 of them. Or a multiple of 7. So what are the multiples of 7? Good. And those are the only ones that are there, so that's why we added 3 over 25. And then the overlap. Which ones of these are odd? 7 and 21, so that's why you subtract the 2, the both. Okay, and then drawing an even number or a perfect square. Did you guys forget the number 1 in your perfect square list? That was the one that I was worried about. So 1 is a perfect square. Square root of 1 is 1. So an even number out of 1 through 25 is 12 out of 25. Okay, because 1 and 25 are both odds. And then the perfect squares up through 25 are 1, 4, 9, 16, 25. So there are 5 of them. And then you subtract the ones that are both even and a perfect square. So that would be 4 and 16. Okay, so that is going to give you 15 over 25. And then you just reduce. Yeah. Kevin?
Why do you have to do all the perfect squares to 25 if it has to?
So anytime it's the or, if it's or a perfect square, then it includes the ones that are a perfect square. So or means that it doesn't have to be both at the same time. If it was and, then you wouldn't have to. Yeah, so with probability, I think the hardest part is some of the language. It's very subtle, like a or and an and or a given. Sometimes that's the only thing that's different. Okay, and then 14. Now, we've been doing a lot of two-way tables. This is not a two-way table, though. Okay, this is a table of your volunteers, and then you also have the doses, okay, in the 3 different groups. So the total number of volunteers is 353 plus 467 plus 310. So this is the total number of people. These represent the doses. So it says, if a volunteer is chosen randomly, what is the probability that the person receives the highest amount per day? The highest amount per day is the 250 milligrams. The number of people is 310. So there's 310 people that receive the highest dose out of the 1,130, and then you just reduce it, and that one just gets reduced by 10. Okay, and then this one, if a volunteer is chosen randomly, what's the probability that they receive more than 150 milligrams? So that means they either receive 200 milligrams or 250. So the 200 milligrams, there are 467, that is a 6. And then the 250 is 310, so you just add them together. That's how you get the 777. And then it's still out of the total. And then the last one is, let's say the person does not receive 200 milligrams a day. So you could just look at your table. They don't receive 200. That means they receive 150 or 250. Add them together, and then that's going to go over the total. Okay, so I kind of thought 17, 18, and 19 were the hardest. How did those go?
Really bad.
Okay, so good thing we're going over them. You can see here, one thing I do is I make a little table for myself to organize the information. Okay, this is important stuff to do on this test, but when we get back from spring break, we're going to be doing SAT, PSAT stuff. And that's important too, to start organizing the information. So the English class has 28 students. So see how I just write down 28 total? He has 6 ESL students, so 6 ESL. And just in case you guys don't know, that means English is their second language. And then 10 remedial students, so 10 here. And again, I'm just organizing the information. And then 5 advanced learners. Okay? ESL students make up 1/5 of the remedial and 3/5 of the advanced learners. So when they ask you what's the probability that a student is ESL and remedial, okay, it says ESL makes up 1/5 of the remedial. So how many remedial students are there? 10. So all we have to do is multiply that by 1/5, and that will be 2. Okay, so then you're going to put 2 over the total, and the total is 28. Okay, so because they said 1/5 of the remedial is ESL, we just take the number of remedial, multiply 1 by 1/5, okay, and that's how many we have out of the total. And then we're just reducing. So 2 out of 28 reduces. So this one's going to be similar, a similar process. What is the probability that a student is ESL and an advanced learner? So it says ESL students make up 3/5 of the advanced learners. Okay, so we have to find how many advanced learners there are. There are 5, and we're going to multiply that by 3/5. So 5 times 3/5 is going to be 3, and then you put that over the total. That doesn't reduce, so it'll just be 3 over 28. Okay, now this one, we have to do some more mathing here. So what is the probability that a student is remedial and not ESL? Okay, so the first thing I did is took the amount of remedial, which we know is 10, that's given to us, and then let's subtract the ones that are remedial and ESL, because we found that out in the first one. We found that there were 2 who were ESL and remedial, so we're just going to subtract them, and that means there's 8 that are remedial and not ESL. Okay, so 8 would go over the total, 8 over 28, and then you just reduce your fraction. Okay. All right, and then for 20, a student is collecting a population of laboratory mice to be used in an experiment. He finds that of the 236 mice in the lab, 173 mice are female, and 99 have pink eyes. Just 10 of the pink-eyed mice are male. Okay, what is the probability that a mouse is female or has pink eyes? Okay, how did this one go? Okay, so then how did you guys set this one up?
The probability of it being a female plus the probability of having pink eyes, and then subtract the probability of it being female.
Okay. And then do you guys know what word tells you that? Yes. And I just put both. So I always think of it like this. Female, pink eyes, and then minus the probability of both. Okay, so 173 are the total female. The total with pink eyes are 99. Sorry. Keep working. Are you done? Oh, okay. And then, how many are your both? Pink eyes and female. So if 10 of the mice are male, out of the 99 pink eyes, 10 are male, 89 are female. And then, so again, if it doesn't say to write as a decimal fraction, except this last one, I should have told you to do that. I'm sorry. Okay, and then the last one is the probability that at least 2 of the friends will choose the same screensaver for their computer. This is cute. These are screensavers for your computers. I think you probably just use the default ones. So a group of 4 friends buys a CD of computer screensavers If there's a total of 12 screensavers on the CD, what's the probability that at least 2 of them will choose the same screensaver for the computer? So it's a lot easier to do the probability that they all choose something different. So 1 minus the probability that they all choose something different. So if there are 12 screensavers, the total is going to be 12 to the 4th. But on the top, if they all choose something different, the first person can pick from any of the 12, the next person has the 11, the next person has the 10, and then the last person only has 9. Okay, so if you wrote it as a fraction, I did write that out and then reduced it. But this one, I am going to have you write it as a decimal. So 1 minus 0.57 will be